Hello everyone. So today I'm going to solve a couple of problems on the development length and cutoff. So I'm going to start with the first problem. So in today's class, the first problem. So I can just write down. This is the problem number one. I can make a full screen. So yeah. So the problem one. So what we are trying to solve it. So it's trying to calculate the development length. Development length. LD. So there is a beam given. I can try to draw the beam. This is a beam, long section, simply supported beam. Simply supported beam. And the steel rebar for the, and there's a column, and there's a column, and there are two layers of steel rebar, and the cross section is like this. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So total 10, 30 ambers. And for the moment, so this 10 30 amperes, it is designed for the moment. It's sufficient for the moment. And what else is given? The other given is total span is 10 meters. So it is like from the middle span, it's like 5 meter, 5 meters, 5 meter, 5 meters. So the question is, this is the simply supported beam, and for the moment it's sufficient to do this 10-30 meter bars, and total span is 10 meter. The question is, what is the development length for the steel rivers, so that it can develop the strength, sufficient strength. And also, if also the question one is, what is the development length, and question two is, check whether the development length, or the development length is sufficient sufficient or not. Like, is the development length can be fit into the beam span or not. Is the, I can delete this. So check if the bar length is adequate or not, whether the steel river is adequate for this design or not. So the steel river is 10 meter and half 5 meter from the center. So if sufficient or not, if sufficient or not, if the steel river length is sufficient or not. Okay, so now let's start solving the problem. Oh, there's another two other thing given, that still Fy is given 400 MPa, and concrete strength is also given as 25 MPa, which is normal density concrete. So okay, let me try to solve the problem. I can change the color for the solution. So green. Okay, for the solution. So what do you know? So from the given information, we can say that K1 value is 1, since it is bottom bar. We can also say that K2 is also 1 since it is regular uncoated river. Since it is regular uncoated river. And we can also say that K3 value is also 1 because it's a normal density concrete. Normal density concrete. We can also say K4 is equals to 1 because it is 30 amper because of the bar size. And if you put all of them in the equation, we can calculate LD. LD equals to 0.45, K1, K2, K3, K4 multiply Fy F prime C multiply dB. So we can put all the values 0.45, 1, 1, 1, 1 multiply 400. Oh, there's a in the equation there is a square root. 400 divided by square root 25 and bar dia. So as I mentioned in the class, you're supposed to do the actual bar diameter instead of the 30. But for simplicity, for this particular example, I'm just assuming 30. But if it is in the final exam, you guys should use the actual diameter. And we find that it's 1080 millimeters. So now the second part, check if it is sufficient or not. So what is the available length? Available length for the moment. If I draw the moment diagram, so the moment diagram is something like this, right? It's simply supported beam. Simply supported beam. At the max midpoint, moment is maximum, and that means this is the length required for the development length. So for the development length, you need to go to the middle maximum moment and then go whatever is required to steel rebar is length is required to achieve that strength. So that means the available length available length equals to 10 meter by 2. It's like 5 meter, which is 5000 millimeters. So now if you compare this number and this number, so you can say LD, which is 1010 millimeter required, is less than the 5000 millimeters of the beam span. So that means if you provide the steel rebar all the way to the end, so then it is sufficient. So this length LD equals to 1080 millimeter, and also this length, this is also LD equals to 1080 millimeters. So we can say that since this LD is less than 5000 millimeter, so it's sufficient length to develop the development length for the steel rebar for achieving this required moment capacity. Okay, so this is the problem 1. So I'm going to make another video for problem 2, and let's see if I can make a third one or not. So this problem set I'm done. So I'll go to the second video for the second problem set.